Welcome back, students. This is the Q&A session 8 from the playlist of JEE Advanced Part 1. The topic is the percentage error from the chapter of units and measurement. And this is the question which was asked in the JEE Advanced paper in the year 2016. Now, the question is, in an experiment, the value of G is given by this equation, that is T is equal to 2 pi under root 7 in bracket capital R minus small r divided by 5G, where T is the time period of a periodic motion, and here the value of R is equal to 60 plus minus 1 millimeter, and the value of small r is equal to 10 plus minus 1 millimeter. The time period of 5 successive measurements are, it is 0.52 seconds, 0.56 seconds, 0.57 seconds, 0.54 seconds and 0.59 seconds. The least point of the watch which was used for measuring this time period is equal to 0.01 seconds. So which of the following are true? So there are 4 options here and we have to find all those options which are correct. So here the first option is the error in the measurement of R is 10%. The error in the measurement of time period is 3.5%, or the error in the measurement of time period is 2%, and the error in the measurement of G. The G is this acceleration due to gravity. So here all the errors in the measurement are given in percentage. So it is basically we have to find the percentage error in our time period and the acceleration due to gravity. So the percentage error in the measurement of R, percentage error in the measurement of R in the measurement of small r, this is equal to, this will be given by delta R divided by R into 100, where delta R is the absolute error. Now here the absolute error in the measurement of small r is 1 mm and the true value of R is 10 mm. So the percentage error in the measurement of small r will be equal to 1 divided by 10 into 100. So this is equal to 10%. So our first option is correct. That is, the error in the measurement of R is 10%. So this option, that is the first option, is correct. Now we have to find the percentage error in the measurement of time period and the acceleration due to gravity. So here the time period of 5 successive measurements are 0.52, 0.56, 0.57, 0.54 and 0.59. So in order to find the percentage error in the measurement of time period, we have to first of all find the mean value of these 5 time periods. So the mean value of the time period this will be equal to 0.52 plus 0.56 plus 0.57 plus 0.54 plus 0.59, and this will be divided by the total number of measurements. So the total number of measurements is equal to 5. So here the value will be equal to that is equal to 2.78, and if I divide it by 5, so this will be equal to 0.556. So this can be written as 0.56 mm. So the mean value of the time period is equal to 0.56. Now the next step will be to find the absolute error in the measurement of the individual measurement. So the absolute error, that is, let's say delta T 1, this is the absolute error in the measurement of the first time period. which is equal to 0.52. So the absolute error in the measurement of the first time period, that is say delta t1, this will be equal to the true value. Now here in this case, the true value will be taken as the mean value of the time period. So this will be equal to 0.56 minus 0.52. So this is equal to 0.04 mm. Similarly, the absolute error in the measurement of the second time period, this is equal to 0.56 minus 0.56. So this is equal to 0 mm. Similarly, the absolute error in the measurement of the third time period, this will be equal to 0.56 minus 0.54. So this will be equal to 0.02 mm, and the absolute error in the measurement of the fourth time period, this will be equal to 0.56 minus 0.59, and this is equal to so this will be equal now. These all the errors are to be taken as positive, and this value will be equal to 0.03 mm. While calculating the error in any sort of measurement, we have to add all the errors due to the different measurements. So in this case, so all the absolute error has to be taken as positive. So in this case, the value was negative. However, since the error is has to be taken as positive, so this will be equal to 0.03 mm. Similarly, the value of the last that is the fifth time period, the absolute error in the measurement of the fifth time period, this will be equal to the measurement, the absolute error in the measurement of the first one is 0.52, 0.56. Sorry, this is the absolute error in the measurement of the fourth time period, and this is the absolute error in the measurement of the fifth time period. So we have to calculate the absolute error in the measurement of the third time period. So let us calculate this one also. This will be equal to 0.56 minus 0.57. So this will be equal to 0.01 mm. So this is the second step. Now we have to find the mean absolute error. So we will simply, in order to find the mean absolute error, so first of all, I will just write down the mean value of time period here. That is, I am just writing here as T mean. So this is equal to 0.56 mm. Now the mean absolute error, this will be equal to 0.04 plus 0 plus 0.01 plus 0.02 plus 0.03 divided by the total number of measurements. So this is equal to 0.04 plus 0 plus 0.02 plus 0.03 plus 0.01. This is equal to 0.1, and 0.1 divided by 5. This is equal to 0.02. So the mean absolute error is equal to 0.02 mm. Now the next step is we have to find the percentage error in the measurement of t. So the percentage error in the measurement of t, measurement of time period, this will be equal to the mean absolute error, that is 0.02, divided by the true value of this time period. But in this case, the true value will be taken as the mean value of the time period, and the mean value of the time period was equal to 0.56 into 100. So this is equal to 3.57. 3.57%. So the percentage error in the measurement of t is equal to 3.57. So the second option is also correct. So since the error in the measurement of t is 3.57, so the third option will not be correct because it is given as 2%. Now the last is we have to find the error in the measurement of the acceleration due to gravity. So this is a very easy question. The only thing is that involves some amount of this mathematical calculation. Otherwise, the question is very easy. Now, here the formula for the time period is equal to 2 pi under root 7 r minus r divided by 5g. So if I square this equation on both sides, so I will be getting t square is equal to 4 pi square and into 7 r minus r divided by 5g. So from here, the value of the acceleration due to gravity is equal to 4 pi square upon 5, and this 7 into 4 will be 28. So 28 pi square upon 5 into r minus r divided by t square. Now 28 pi square upon 5 is a constant, so it will not be considered while calculating the percentage error in the measurement of the acceleration due to gravity. So delta g upon g into 100. Now delta g upon g is basically the percentage error in the measurement of g. Now this constant will not be considered in the measurement of the percentage error. So simply I will be getting the percentage error in the measurement of g as, now here it is t square, so this will be equal to 2 times delta t by t into 100 plus, now here the r is a measurement which is equal to 60 plus minus 1 mm, and small r is another measurement which is equal to 10 plus minus 1 mm. So 60 is the true value of this this of r, capital R, and 10 mm is the true value of the measurement of small r. So here in this case, since we have to add up all the errors while calculating the total error in any measurement, therefore this equation will get converted into 2 times delta t into delta t divided by 2 into 100, and plus this will be equal to delta r plus delta r. That is this is the absolute error in the measurement of this value, that is capital R, and delta r is the absolute error in the measurement of this small r, divided by r plus r into 100. So this will be equal to 2 times, now delta t upon t into 100 is the percentage error in the measurement of this time period, and this was equal to 3.57. So this will be written as 3.57 plus, now delta r here is the absolute error in the measurement of capital R, and the delta r small r is the absolute error in the measurement of small r. So this will be equal to 1. So here the delta r, that delta capital R is equal to 1 mm, and delta small r is equal to 1 mm. So this will be equal to 2 mm divided by r plus r. Now r plus r will be this will be equal to r minus r, because here in this expression the value is r minus r. So this will be equal to r minus r, this will be equal to 50. It is 60 minus 10 into 100. So this is equal to 2. So finally, if I just multiply it, that is 3.5 into 2 will be approximately equal to 7. 7 plus 4, that is equal to, so this value will be approximately equal to 11%. Okay? So the percentage error in the measurement of G is also equal to 11%. So the correct options are A, B and D. So in this question, there are 3 options which are correct, and the most important thing here, which you all have to remember, is that while calculating the errors in any measurement, the error due to the individual measurement, or you can say the error in the measurement of any physical quantity which is leading to the value of another physical quantity has to be added up. Okay, so that is the first important thing. Then other important thing was that the percentage error is basically equal to the percentage error is equal to the absolute error divided by the true value into 100, and in case the true value is not given, then in that case what we do is, that is in the case of time period, the true value was not given to us, so we have taken the mean value of the 5 measurements, and that mean value was taken as a true value. So this was the another formula which we have used in this question, and I hope that you have understood the solution of this question. So in the normally in the advanced paper, there are more than one options which are normally found to be correct. So in this question there were 3 options, that is A, B and D, which are found to be correct. And in the next session I will be taking up another question now, but that will be from the chapter of motion in a straight line. And so till then, have a nice day. Bye.